Welcome to another session of Everyday Mathematics. Today's problem is problem number 3 of the MIT 2024 Integration Bee Quarterfinals number 3, which is the limit as n tends to infinity of 1 over n times the integral from x equals to 0 to x equals to n of the maximum of three items. One is the fractional part of x. The other one is the fractional part of square root of 2 times x. The other one is the fractional part of root 3 times x. Very interesting problem. I'd like to thank our subscribers. Thank you so much for keeping it locked. Thank you so much for the support. We don't take that support for granted. For our first-time visitors here at Everyday Mathematics, what we do is we go about and around and look for interesting problems. We come back, we share with you the solutions. For repeating visitors who haven't yet subscribed to our channel, we do really encourage you to consider subscribing to our channel. Your support will really go a long way in giving us that extra visibility that we need. So on to our problem. So the first thing that I feel inclined to do is doing some substitution. I would let u be equal to x over n such that du dx is 1 over n, such that the product of n and du can be substituted for dx. And then looking at the limits, when x equals to 0, therefore u is 0. When x equals to n, u becomes 1. So this problem here becomes, first of all, for the limits, we saw that it is 0 and 1 here. All right. And then maximum of the fractional part, since n times u is x, where you see x, we have n u, and then square root of 2x becomes square root of 2 nu. Square root of 3x becomes square root of 3 nu, and then dx is n du. And we see that this n and this n would cancel out. Okay. So as we saw previously, we saw that obviously this n's cancel, and we have this beautiful integral of limit n tending to infinity of the integral from x equals to 0 to x equals to 1, the maximum of the fractional part of nu, the fractional part of square root of 2 times nu, and the fractional part of square root of 3 and nu. So since let's just try to understand what the fractional part bit means. So fractional part means is that excess of a real number beyond the integral part. So for example, if we have a fractional part of x, that's the same as x minus the floor function of x. So if we are to plot it, if you have the graph shown here, we have x-axis and then we have y-axis. The floor function, I mean, the value of x is obviously going to be that straight line, right? When x equals to 1, the value of x is 1, when x equals to 2. So it's just going to be a straight line. And then the floor function of x would be between 0 and 1, it's 1. Between 1 and 2, it is 1. Between 2 and 3 is 2. And between 3 and 4, it is 3. So the difference now is going to be between 0 and 1. It's going to be that value of x minus 0 for the entire part. So we just have x. But between 1 and 2, because the value keeps increasing beyond 2, the difference now is just going to be, again, the same value as what we would see in the domain 0 and 1. And it continues like that. So you have like a sawtooth wave like behavior, but the value is limited between 0 and 1, and that's the beauty of this function. It's called a sawtooth wave. Okay, now for this, since we know the the behavior of the fractional part of x. But if you have the fractional part of nx, we decided to change u back to x. It means that when x is equals to 1 over n is when you have that transition back. And then again, this is when we have x equals to 2 over n, right? And then for the fractional part of square root of 2 nx, the transition is at 1 over square root of 2n, 2 over square root of 2n. And then for square root of 3 nx, the same thing, we have 1 over square root of 3n is when you see that transition. So the maximum of this part of this function, all these values lie between 0 and 1, but we are asked to extract only the maximum at any given interval of the 3. And we see in that region, in this domain, this is the maximum. In this domain, we have this as the maximum. In this domain, we have this as the maximum. In this domain, we have this as the maximum. This as a maximum here. This is the maximum for a short interval between this comes in. But as you go on, it becomes stochastic. You know, there's just random values being the maximum, but all lying between 0 and 1. So what this tells us that this integral here is the same as the integral from 0 to 1 of the value of x being obviously 0 and 1 within that, but times a certain probability. So we have to find the probability for which this the value of x shows up, right? As we integrate between 0 and 1. That is what it's telling us. It's more of an expected value of x, given x is the maximum of the 3 different independent variables, and we need to figure out what is that probability. What's the probability for which that a given value of x shows up, right? Now, we do have what we call, since these independent variables have a uniform distribution, if you have a value like this, right? If you have what we call the cumulative distribution function, if the distribution is uniform, then the CDF or cumulative distribution function fx is going to, at the value of x, is going to be x minus the lowest value 0 over the total, which is 1. It's going to be 1 here minus 0. And in this regard, we have x as the CDF for any of those variable fractional part of nu, fractional part of square root of 2 nu and x, and so on. So taking everything into consideration, for the maximum value, it means that we have 3 different variables that are independent, but also less or equal to 1. And this is same as the product of the CDF of each event, right? Which is x times x times x, which is x cubed. But we know that the probability at any given value of x is the derivative of the CDF. So which is the derivative of x cubed, which is 3x squared. Now our integral now becomes the integral of x from x equals to 0 to x equals to 1 of x times fx. We know fx to be 3x squared, and so we have it become the integral from of 3x cubed, and which is, we have 3 out here, and x cubed integrated is x to the power 4 over 4, so with limit 0 and 1. And so that means that the answer is 3 over 4. So this is a very tricky problem, but it just did require a little bit of acrobatics here and there. Now, until next time, it's been an absolute pleasure hanging out with you. For those of us who haven't subscribed, we do really encourage you to subscribe to our channel. But otherwise, see you next time.